Critical points. Okay. Now, critical points technically are when the derivative is equal to 0 or is undefined. Sometimes we just think of them as the undefined ones because when the derivative equals 0, we have another name for those, that being stationary points. But technically, stationary points are critical points as well. So equals 0 or is undefined. So let's have a look at some examples. There's a typical cubic. That would be a critical point because it is a stationary point. In fact, we've got another name for that one because we know that one would be a maximum turning point. And the one down the bottom is a critical point. It is also a stationary point, but that one we would call a minimum turning point. There's our, well, it's also a cubic, but it has what we call a horizontal point of inflection. Again, it is a critical point because it is also a stationary point. Notice, not all points of inflection, by the way, are stationary. Stationary means horizontal tangent. So, I've got a parabola on its side. That one there is one of our classical critical points, what we think of when we say critical points, because that has a vertical tangent. So it's a vertical tangent, the slope of that line would be infinite, so the derivative would be undefined. You wouldn't be able to actually work that out. And then you have what we call cusps. That also is a minimum point. Actually, that's wrong what I've written there. I said it's not continuous. It is continuous. It's not smooth continuous, is what I should have said. So it comes to a sharp point, a bit like the absolute value curve. So it's not differentiable at that point. And so therefore the derivative is undefined, which also makes it a critical point. Okay, that was very quick. You can see.